Every winter, your house fights the cold. Your furnace turns on, burns fuel, pushes hot air through vents, and then shuts off. Minutes later, the heat is gone, and the cycle starts again. Burn, lose, repeat. That's how modern heating works. But what if heat wasn't something you constantly had to produce? What if it was something you could store? 500 years ago, entire homes stayed warm through brutal winters using a single fire each day. Not all day, not constantly burning, just one short, intense fire. And then, nothing. No furnace running, no electricity, no fuel being consumed hour after hour. Yet the house stayed warm for the next 12 to 24 hours. Not by accident, by design. Across different parts of the world, civilizations discovered the same principle independently. The Romans built hypocaust systems that carried heat beneath floors. In Korea, homes were warmed using ondol systems that directed heat through stone channels. In China, the Kang used thermal mass to store and release warmth. Different cultures, different centuries, but the same idea repeated again and again. Heat doesn't need to be constantly generated. It needs to be captured and held. In Northern Europe, this idea evolved into something far more refined: masonry heaters. These were not simple fireplaces. They were engineered thermal systems built from stone, brick, and careful design. Instead of letting heat escape up a chimney, these heaters trapped it, absorbed it, and slowly released it over time. The fire itself was only a small part of the system. The real heater was the structure around it. During the Little Ice Age, when winters became more severe and resources became scarce, this technology became essential. In Sweden, where firewood shortages threatened entire regions, a redesigned masonry heater changed everything. Instead of wasting most of the heat, the system forced hot gases to travel through internal channels before leaving the chimney. As those gases moved, they transferred their heat into the surrounding masonry. By the time they exited, most of the energy had already been captured. This changed heating completely. A short fire could charge the entire structure with heat, and once the fire went out, the bricks continued to release warmth slowly and evenly throughout the day. Homes stayed comfortable without constant fuel consumption. Efficiency wasn't improved slightly, it was transformed. And then something unexpected happened. The system didn't disappear because it failed. It disappeared because something else replaced it. Central heating, electricity, and mass-produced systems entered the market. These systems were easier to install, easier to standardize, and easier to sell. Over time, the older systems were removed, not because they stopped working, but because the world shifted toward convenience and repeat consumption. But the physics behind masonry heaters never changed. In fact, when you look closely, they solve one of the biggest inefficiencies in modern heating. A typical fireplace or wood stove burns at relatively low temperatures, which leads to incomplete combustion. Smoke, wasted fuel, and lost energy go straight out of the chimney. In contrast, a masonry heater burns wood at extremely high temperatures. This allows nearly complete combustion, extracting far more energy from the same amount of fuel. But the real advantage isn't just in how the fire burns, it's in what happens after. The structure itself, often weighing several thousand pounds, acts like a thermal battery. It absorbs heat quickly and releases it slowly. Instead of heating the air directly, it radiates heat into the space. Walls, furniture, and people absorb that warmth, creating a more stable and comfortable environment. This type of heat feels different. It doesn't dry the air or create sudden temperature swings. It's steady, consistent, almost natural. And because the system relies on stored heat rather than continuous combustion, it uses far less fuel overall. Now compare that to modern systems. Furnaces turn on and off constantly. Heat is produced, distributed, and then quickly lost. Energy consumption continues as long as you want to stay warm. Equipment wears out. Components fail. Systems need replacement every 15 to 20 years. And throughout all of this, the dependency never ends. That difference isn't accidental. Modern heating systems are built around ongoing use. They require fuel, electricity, maintenance, and replacement. This creates a cycle where the system itself becomes something you continuously support. A masonry heater breaks that cycle. Once built, it operates with minimal intervention. No motors, no fans, no filters, just structure, heat, and time. So if the system is so effective, why isn't it everywhere? Part of the answer lies in how modern construction evolved. Masonry heaters require planning, craftsmanship, and understanding. They aren't mass-produced units that can be installed in a day. They are built, not assembled. And in a world focused on speed and standardization, that kind of approach became less common. There's also the economic side. Systems that last for generations don't create the same ongoing demand as systems that require regular replacement. A heater that works for decades with minimal maintenance doesn't fit easily into a model based on recurring sales. And then there's awareness. Most people simply don't know these systems exist. They're not taught in standard building practices. They're not commonly shown in modern homes. So the knowledge fades, even though the system itself remains just as effective as it always was. But that doesn't mean it's gone. In fact, it's quietly returning. Builders, homeowners, and designers are starting to revisit these ideas. Not as a step backward, but as a different way of thinking about energy. Instead of constantly producing heat, the focus shifts to storing it. Instead of relying on complex systems, the focus returns to simple, reliable principles. And for those willing to build one, the process is surprisingly achievable. A masonry heater starts with a solid foundation. Because of its weight, it needs proper support, often integrated into the structure of the home. From there, the core is built using refractory materials designed to withstand high temperatures. This core includes the firebox and the internal channels that guide hot gases through the system. Around this core, an outer layer is added. This can be brick, stone, or even soapstone, depending on the design. The outer layer absorbs and radiates heat, creating the steady warmth the system is known for. A chimney connects to the system, carefully designed to maintain proper airflow and draft. Once completed, the heater is gradually cured with small fires to prevent cracking. After that, daily operation becomes simple. A single load of wood is burned quickly and intensely. The heat is absorbed into the structure and then released slowly over the next several hours. The routine is different from modern heating. Instead of constant adjustment, it becomes a rhythm. One fire, then warmth that lasts. And that's what makes this system so different. It doesn't fight the environment, it works with it. It doesn't rely on constant input. It stores energy and releases it when needed. It doesn't wear out quickly. It's designed to endure. For centuries, this was how people heated their homes, not through continuous consumption, but through intelligent design. And while modern systems replaced it, they never improved on its core principle. They simply changed how heat was delivered. Now, that leaves you with a choice. Continue relying on systems that require constant energy, constant maintenance, and constant replacement. Or consider a system that, once built, does most of the work on its own, because the materials haven't changed, the physics hasn't changed, and the solution has been here the entire time. If this changed the way you think about heating, subscribe, because the next system might completely change how you think about building your home altogether.